Hello, you are welcome once again to SHS 1 Additional Mathematics. SHS 1 Additional Mathematics. And in this video, we are looking at the strand modeling with algebra. The substrand is number and algebraic patterns. In our previous lessons, we were looking at the very indicator binary operation, that is recognizing binary operations and apply the knowledge in solving related problems. In this lesson, we are going to look at indicator number 2. So the first two videos talked about indicator number 1 when we look at the binary operation, the concept of it, what it is about, and then its application, right? Now this video number 3, we are looking at indicator number 2, which is describe and interpret the characteristics of commutative, associative, distributive, and closure. So we want to find out what is commutative, we want to find out what is associative, distributive, and closure, all under this very indicator. And since I'm using a free version of Screen Power, which in fact we acknowledge them for giving us this wonderful software to use in recording lessons, we can only do maximum of 15 minutes. Okay, maximum of 15 minutes. And that is okay for me because I don't want my videos to be quite lengthy for you. So let's start with what is commutative property under binary operation. So properties of binary operation. We want to start with commutative property. So this video is going to be only commutative property. Our next video we will look at associative, and we're doing it little by little. So make sure you watch all the series so that you can get everything without mixing any of these properties. So let's talk about commutative property. What is commutative property? Okay, what is commutative property? In our previous school, I mean primary school through junior high school, we're told that if you have 2 plus 3, or you do 3 plus 2, the first one and the second one will be the same. The left hand side will be the same as the right hand side. Each of them will give you 5 and 5, right? Again, if you have, let's say, 4 times 5, 5 times 4, here we are saying that if you multiply 4 times 5, that gives you 20. 5 times 4 will give you 20. So the left hand side is equal to the right hand side. So based on our previous lesson, we know that addition is commutative, multiplication is commutative, because we don't care about which number we multiply first or we add first. Anytime we do two operations, or sorry, binary operation, we always get multiplication being commutative and addition also being commutative. Let's say I give you 5 minus 3 and do 3 minus 5. Am I going to get the same thing on the left hand side to that of the right hand side? The answer is no, because the first one will give me just 2, second one will give me negative 2. And since this is not equal to that, we'll say the symbol subtraction is not commutative. I hope it makes sense. The subtraction is not commutative. Again, if I have 10 divided by 2, 2 divided by 10, while this is giving me 5, this one is giving me 1 over 5, and they are not the same. And so we say division is not commutative. The same idea we are going to carry to understand binary operation when we use symbols like star, triangles, and so on and so forth. So by binary operation defining commutative, we are saying that when operation is said to be commutative, it must satisfy this condition that A star B should be equal to B star A. So even if I use a symbol like A triangle B and it's equals to B triangle A, we'll say that operation triangle is commutative, or operation star is commutative. And this must be true for all elements that are found in the set that we are defining the commutative property in. I hope that makes sense. Now let's look at it in terms of your life experience. So maybe further explanation will help you. When order does not matter, adding items to a shopping cart, for example, you go to any of the shopping malls and you are buying items in a basket, and you put 5 books in a basket and put 3 pens in addition to that. Your content will be the same as you putting 3 pens first into the basket before putting in 5 books into the same basket. It will be the same, nothing changes. And so we are saying that here your adding the 2 items will remain commutative. Look at it from this point too. Having your socks and your shoe. Wearing the socks first, then you put on your shoe. This time around, look at it from wearing the shoe first before putting on the socks. Are you going to have the same outcome? The answer is no. And so here, we wearing socks, adding socks to shoe or shoe to socks, in terms of wearing them, is not commutative. It's not commutative. I hope it makes sense. Good. So, example, let's see maybe a question. How we can apply this idea to solve questions. Here, I want to show that binary operation R defined by this, okay, A star B is commutative. How do we prove this? We know that for A star B to be equal to B star A, that means operation star is commutative. Now, by definition over here, A star B means I have 1 plus AB. And when I come to this side, I'm going to have B star A. That means B must come first. So that also gives me 1 plus BA. Now, check. Your left-hand side, your right-hand side, are they the same? Yes, they are the same. And so we can say here the operation star is commutative. Good. Let's take another example and see. Let's have a question like this again. A binary operation star is defined on the set R of real numbers by this statement. Determine whether or not the operation star is commutative. And then 2, find the truth set of P operation 4 equals 9. Right. Now, our aim is to see whether this particular star this time around will be commutative or not. So let's see how we'll handle this question. So we know that for operation to be commutative, then P operation Q should be the same as Q operation P. This is our definition. So on the left hand side here, we are going to define it by that. So P squared minus 2PQ. On the right hand side, this time around the Q is coming first. So it's going to be Q rather squared minus 2QP. Sorry, P. Now, my question for you is this. Are the information on the left hand side equal to that of the right hand side? You can pause the video and think a little bit about that. It is obvious that they are not the same, because if I pick a number called P and I square it and I subtract this, it won't be the same as pick another number called Q and subtract the same thing, because this part will be the same as what is coming here. But since P squared will not be the same as Q squared, because P and Q are not the same number, and so we will say that since left hand side is not equal to the right hand side, therefore operation star, so I have to write that, therefore operation star is not commutative. That's it. Then you conclude it's not, because the question says determine whether or not, so it is not. Then the second part of the equation is this. They want you to do P star 4 equals 9. So what is P star 4? By definition, P comes first, 4 comes second. And so P squared minus 2 times P again times 4. All should be equal to 9. If I simplify this further, it will give me 8P. And if I move this one here, I get this. And this is a quadratic equation, which you have to use quadratic means to solve it. And I'm sure you can do this. So I will leave that for you to solve for this. Okay? If you don't know how to do this, search for the video on quadratic equation and you'll be able to understand this. Now, another question for you, which I'm not going to do, but I'll guide you through to solve on your own. They said Mn is defined as negative this over that. Okay, show whether or not the operation star here is commutative. So For the operation to be commutative, they should be equal. And so when I put m and n into this as the equation has given me, which of course is going to be negative n over m squared plus 1, if it is equal to this time around, the m will come first over n squared plus 1. Would the left hand side be the same as the right hand side? I will leave that for you to decide, to tell whether it is commutative or not. Right. It is not commutative, right? The answer has even come here. Okay, then the next one also here is determine whether or not the operation star here is commutative. That's your assignment. Pause the video, try your hand on it, then you proceed. Right. It is not. Again, it is not. But I'm sure you did that before you saw that it is not. Good. Then the last question I will leave with you is this. The binary operation, this symbol, star with a dot inside, is defined on the set P, which is XYZ, by the table below. Determine whether the operation this is commutative or not. Determine whether it's commutative or not. Now, yours is just to look at it and say, okay, S star S gave me X. X star Y gave me this. This star this gave me that. If you go the reverse and you do Y star this gave me this. This star this gave me that. This star this gave me this. And the left hand side becomes the same as the right hand side. Then you can make your conclusion. I wouldn't do that for you. Go ahead and solve this on your own. I'm sure this has really helped you to understand what is commutative property under binary operation. Thanks so much for watching. Meet you another time.